Hi guys, welcome back to revision class series. As I told in this session, we will be focusing on TRB and Barc exam mainly. Here, let us continue the lecture. So whoever are preparing for TRB or if you are specially preparing for Barc exam, so here we will be covering the whole syllabus for all this. Let's start from the beginning. So in the last class, where we left, we have been discussed about continuous time Fourier transform. It is completed fully. Then we were also in the previous classes we were discussed about discrete Fourier series. We saw all the formulas, properties, important things, everything we have seen. Then in continuous time Fourier transformation also what we did the same. Like we have started from the beginning, basics. Then we have gone through all important things whatever are required for the exam. Then I taught you clearly how to apply the properties of duality, how to play with that. We have seen the importance of rectangular functions, how to convert and how to write it in sync format. Then we have seen other important formulas, Pascal theorem, how to apply. There are so many things we were covered. Now, in this session, we will be continuing from the next one. We will start from discrete time Fourier transform. That is what we are going to discuss next. So, what is this discrete time Fourier transform? Just to convert, let's see. If you are observing, the first most important thing is we are having two domain. If I am having something in a time domain, that is n domain. N is a time in discrete domain. How to convert this into frequency domain? So in case of discrete domain, sometimes what people will do is they will be writing directly x of omega to represent that the given signal is in frequency domain. The other way of representing this given signal is we can also write x of e power j times of omega. That is the another way of representing the signal in discrete domain. So discrete time Fourier transform. Now let's continue from the beginning. As we are observing, we have to transform the signal. If I have something in n domain, if you are willing to transform it into frequency domain, omega domain, how should I shift it? What is the basic formula that we are standardly using here? So the basic formula is x of e power j times of omega can also be represented like this. I have already told you. Either people will be writing like this or they will also write the frequency in this form. So don't get confusion. In order to avoid the confusion when we are facing this type of equations in the examination, I am directly writing in this same format. So x of e power j omega, this can be written as summation. The formula is summation n equal to minus infinity to plus infinity. We have a signal x of n into dot e power minus j times of omega n. As I told, I am changing the representation of the omega. I will be using the another format. So this is also called omega only. Understood, sir? So this is the first most important thing that you must keep it in your mind. When some signal, random signal will be given in the examination, what they will ask is find out the corresponding discrete time Fourier transform. At that time, if you don't remember the general formula, it may lead to lose the mark unnecessarily. So do remember this formula a little bit important one. Of course, you should remember it. Fine, sir. Next one, whenever we are focusing on discrete time Fourier transformation, the one and only thing is whenever we are applying discrete Fourier transformation for any equation, what will be the sufficient conditions to apply discrete time Fourier transform? What will be the sufficient condition? The one and only sufficient condition is to apply discrete time Fourier transformation is when the moment you are finding the summation of a signal. For an example, I am running a signal from minus infinity to plus infinity. When we are finding the sum of the whole signal from minus infinity to plus infinity, the resultant value must be less than infinity. It should not be approaching to infinity. It should be finite. So the resultant value should be summable. That is the one and only sufficient condition to apply discrete time Fourier transform. You must remember this condition. That is a little bit important. Understand, sir? That's it. Now let's continue. I'm just showing one small example. For an example, suppose in the exam it is given that find the discrete time Fourier transformation of step signal u of n. How will you do this? For this, suppose you don't know. See, Don't directly write. Some of you are blindly do some mistake. What mistake I will tell you. You know u of t is called a step signal. For this, Laplace of u of t is going to be 1 upon s. And in Fourier transform also, we have seen that it became 1 by j omega, plus apart from that we have also considered that pi into del of omega also will be concluded with this. So these are all the two standard format that we have seen for step signal. So your mind will be only linking with these two things. You will be forgetting that we are in discrete time Fourier transform. In discrete time Fourier transformation, we will be considering only samples 1 at n equal to 2 at n equal to 3. We are calculating the values. And in this series, the representation of step signal in the frequency domain will be completely different from the normal representation, from continuous domain representation. Let's see. The question is what we want, x of n equal to u of n. Its correspondent discrete time Fourier transformation is what we are looking for. Yes. How should I figure it out, sir? Let's see. The formula is, just now we have seen, when I am trying to convert it into frequency domain, e power j, how to write here? Omega. So this will be equal to summation, formula what we saw is n equal to minus infinity to plus infinity into x of n, whatever the value that you obtained, put it here, e power minus j times of omega n. This is the formula. So as I am writing omega equal to, sometimes I will be writing the home symbol, otherwise I will be writing omega. Don't get confusion, both are same. I met multiple times repeatedly saying. Now we know x of n. In place of x of n, what I am going to put is, we are going to travel from minus infinity to plus infinity. We need discrete time Fourier transformation of a step signal u of n into e power minus j times of omega n. This is what we want. And what we know is step signal u of n. What will be the period of step signal, sir? Anyone? What will be the period of step signal? Step signal will always be running from 0 to infinity. If I am asking you to define the period of step signal, you should define like this. This value is 1, where the value of n will be approaching from 0 to infinity, and its value is 0 elsewhere. In all other place, this value will become 0. So from this, what I can define here is, the value of the given step signal is going to be 1 only from n equal to 0 to infinity. In other zone, this value will be 0 dot e power minus j times of omega n. Let's continue. Now if we are substituting the values for n in the power of e power j omega n, let's see what will happen. Keep n equal to 0, what will be getting? If I am putting n equal to 0, I will be getting 1, e power 0 will become 1. If you are putting n equal to 1, you will be getting minus e power minus j omega. If you are putting n equal to 2, you will be getting e power minus j times of 2 times of omega. If you are putting n equal to 3, you will be getting e power minus j times of 3 times of omega plus etc. and so on. Now from here, what you have to understand here is, this expression can also be written as 1 plus, just focus on this, e power j omega whole power 1, can I write like this, plus the second expression can be written as e power minus j omega whole square. The third expression can be written as e power minus j times of omega whole power 3 plus and so on. If you are observing this series carefully, it will be similar to 1 minus the Taylor series expansion of 1 minus x whole inverse can be written as 1 plus x power 1 plus x power 2 plus x power 3 plus etc. This is how we are writing this expression. So it is similar to that one. In place of x, we are just having e power minus j omega. So this expression can be written as 1 minus e power minus j omega whole inverse. In place of omega, just keep any one symbol. Don't get confusion. Both are same. So whole power, what is 1 minus x whole power minus, or it can be written as 1 upon 1 minus e power minus j omega. This question has been asked in the last TRB exam also. You can cross check once. So what you have to do, whenever they are giving this signal, you must know how to explore, how to reduce the expression. You have to practice yourself. So just to do, remember the general formula. It doesn't matter whether you are remembering something else or not. So you must remember the general property. If you remember the Dtft formula, whatever the signal that they are giving, directly put into the equation and try to expand it and figure out the final answer. That's it. So this is how we are applying Dtft for a random signal whenever it will be given in the examination. Hope you understand how to do this. Now let us enter into the another formula, that is inverse discrete time Fourier transform. So when we are discussing about inverse discrete time Fourier transform, how it can be defined? Let me define. So the inverse discrete time Fourier transform means I am having x of e power j omega, I need x of n. So the standard formula is as usual, you can take 1 by 2 pi integral will be running from minus pi to plus pi, there is no doubt, and here it is going to be x of e power j times of omega dot e power j times of omega n. Sir, in place of omega we can use two type of symbol, don't forget, don't get confusion with this. When it will be given in the examination, you should be very careful that yes, both are same only. Understood, sir? So this is the formula to obtain the inverse discrete time Fourier transform. Hope you understand what I am trying to say. So if something will be given in the examination, sometimes you can use the direct formula. Otherwise, you can also solve it with the by using your mind. See, I will tell you for an example. Suppose it is given that, let us assume in the frequency domain, in inverse discrete domain, suppose if some example question I am taking. Let us assume in the question it is given that x of e power j omega has been defined. Just I am taking some example. 1 plus cos omega plus sine 3 omega. This is what given in the question. You just randomly take some value, that's it. Don't think too much, or else you can also take some other value. Wait, I will take some large value also. So what you can take is, let me take 6 omega. Now what we need is, we just wanted to know the correspondent sequence in n domain, xn sequence. How should I write down its xn sequence in time domain? What I will have to take, sir? I will have to take inverse discrete time Fourier transformation. We will have to do the inverse process. So one and only thing what you have to remember is, whenever we are in discrete domain, especially in Dtft, the formulas, we have some basic formulas in our hand. Cos theta can be written as e power j times of theta plus e power minus j times of theta by 2. Similarly, if you have sin theta, how will you write down? The alternative way of writing the sin theta is e power j times of theta minus e power minus j times of theta upon 2 into factor j also will come along with that. You must remember these two things. That is very, very important. Otherwise, you will not be able to give the correct answer for the expression. Now, let us expand this series. How should I write down the series, sir? This can be written as 1 is 1 only plus cos omega can be written as e power j times of omega plus e power minus j times of omega. Each and every term has been divided by the factor of 2, because in the formula we have denominator 2 plus sin 6 omega. This can be written as e power j times of 6 omega, yes, plus e power, sorry, here it will be minus e power minus j times of 6 omega, minus j times of 6 omega, 1 upon 2j will be the answer. 1 upon 2j you will have to keep here. Now after that, it is your responsibility to write down the correspondent sequence. Sir, how should I explore the sequence? Let me tell you. Always remember, what is your center point here? Just rewrite the sequence from negative to positive zone. Like, start from the least negative value, minus 1 by 2 into e power minus j6 omega. After that, the next negative frequency will be plus 1 by 2 into e power minus j omega. Then write down the DC gain, that is lies at the origin, 1 into e power j0, this value, plus here what will you write? You can write e power plus j omega first term, along with that factor 1 by 2 also will come, and here 1 by 2j will come. Hope I forget to see, I missed one more thing. This will be minus. Is it plus only? 1 second. Okay, see there, e power minus j6, its coefficient is minus 1 by 2j. Next, e power minus j omega, its coefficient is plus 1 by 2, correct? So 1, 1, then it will become plus e power j times of 6 omega, yes, and this is going to be 1 by 2j. Finish, that's it. Now what you have to do is, just to focus on this, the general formula, in place of here e power, what we have, jn into omega. Now observe the values of n. So here this is center point. At n equal to 0, you can obtain this value. Then here if you observe at n equal to 1, we are obtaining this value. And this value we are getting at n equal to 6. And this value we are getting n equal to minus 1. And this value we are getting n equal to minus 6. Then how will you form the sequence, sir? Now I will tell you how to write down this. So the general sequence, anyway this is the final answer in omega domain. If you are writing it in correspondent n domain, then the sequence can be written as at n equal to 0. At n equal to 0 we have value 1. At n equal to 1 we have, what is the value we have? At n equal to 1 we have 1 by 2. At n equal to 2, 0. N equal to 3, 0. N equal to 4, 0. N equal to 5, 0. N equal to 6 we have 1 by 2j. Similarly on the left hand side, at n equal to minus 1 we have 1 by 2. At n equal to minus 2, 0. Minus 3, 0. Minus 4, 0. Minus 5, 0. At last we have minus 1 by 2j at n equal to 6, minus 6. Understand, sir? This is, if they are asking you to form the sequence, only they will give two waveforms. Either they will give sine or they will give cos. You just remember this sequence. This is a little bit important. This is how we are converting whenever a signal will be given. That is how you should transform it from discrete domain inverse to what I can say corresponding n domain. Hope you understand what I am trying to conclude from here. That's it, sir. So this is all about the basics. Now let us see some of the properties of discrete time Fourier transform. They are also a little bit important properties. The first most important property is, as usual, linear property. It is similar. As we already see the linear properties, are the linear properties of the continuous time Fourier series, then continuous time Fourier transform. Now the property number 1 is linearity. The property number 1 is linearity. Suppose let us say I am having a signal x1 of n. Its correspondent value in frequency domain can be written as x1 of e power j times of omega. Now assume I have one more signal, that is x2 of n. Its correspondent Fourier transform can be written as x2 of e power j times of omega. Now what is the question is, from the linearity property, instead of passing, see, first what we are doing here is, we are passing one signal x1 of n and x2 of n separately, and if you are clubbing these two signals together, then what you will be getting here, x1 of e power j omega plus x2 of e power j omega is what we are getting when we are clubbing these two signals. Now instead of clubbing them outside on the frequency domain, if you are clubbing these two signals on the input side itself, then what will be the output? If you are clubbing them directly on the input side itself, that is additivity property actually. We are following additivity property. Then this will give you same answer, x1 of e power j omega plus x2 of e power j omega. So what is the conclusion here, sir? These both are same. This resultant both are same. That is called the linearity property. So whenever you are checking any signal, whether it is linear or not, you can standardly just to follow these basic properties. That will help you to understand very well. The another most important property is time shifting property. So let us go ahead. The next most important property is time shifting property. So the next most important property is time shifting property. So whenever we are observing time shifting property, now let us see what will happen. In case of time shifting property, suppose let us assume you have a signal x of n and its correspondent Fourier transform can be written as x of e power j omega. Now if I am shifting this signal by some version, for an example, if it is shifted to plus n naught, then same thing, what will happen? If you are shifting it here n times, it will be shifted, then in frequency domain e power j times of omega, n will be replaced by n naught. I will write n first. N will be replaced by n naught. Since it is plus here, then here also it will be plus only. Sign will not change. We know whenever we are doing time shifting, sign will not change. But in frequency shifting, sign will change. Sign will change. Into what is the correspondent value? E power j times of omega. That's it, sir. Suppose if we are considering x of n minus n naught then its correspondent Fourier transform can be written as e power minus j times of n naught into omega into x of e power j times of omega. Understood, sir? So whenever we are applying shifting property, it is very important to keep these things in your mind. And the next thing is, if we are observing the signal that we are playing in discrete time domain, of course the given signal is having a certain periodicity property. The another most important property is periodicity. So let me show you the next most important property. What they will ask is, from the periodicity property, if your signal is a periodic signal, then how will you write down the conclusion for the periodic signal? Sir, if you observe in continuous time domain, whenever we are having a basic signal, let us assume I am having a basic signal. How will you identify whether the given basic signal is a periodic signal or not? What will be the condition to identify whether the given signal is a periodic signal or not? The basic condition is, I am considering a certain time period. If the value of x of t is equal to x of t plus or minus t. So after a certain time period, if your signal nature will be again and again repeated. For an example, if I am taking sinusoidal signal, we all very well know that sinusoidal will always be repeating its property after each and every 2 pi. We have started from 0. Let us assume this is pi, and this will become 2 pi, and this will going to be 3 pi, 4 pi, and so on. But now, what will be the periodicity? What will be the period, fundamental period of the sinusoidal signal? Why we are calling it as 2 pi? The reason why we are considering this fundamental period is 2 pi is, after 2 pi, same nature will be again repeated, same sinusoidal. After 4 pi, again it will be repeated. That is the nature of periodic signal. And so here what we are trying to find is, for a particular fundamental time period, after a particular fundamental time period, whether the same signal will be repeating or not. That is the condition to check whether the signal is periodic or not. In discrete domain also, of course, we are doing the same. So since we are writing it in the power of exponential, for an example, periodic, if I have a general signal x of n, its correspondent Fourier transform, we will be writing it as what? X of e power j omega. Now in the frequency domain, what will be the condition for periodicity? That is the question. What will be the condition for periodicity? It is very simple. In case of periodic signal, as we are observing here, x of t equal to x of t plus or minus t, it can be written as e power j times of omega should be equal to x of e power. What should happen here, sir? After each and every 2 pi, nature of the signal should get repeated. So omega plus or minus 2 pi. Either you can consider positive side or you can consider negative side. So the general conclusion is, this will be the finest conclusion for the periodicity condition. So you will have to check by using this. You can easily identify whether the given signal is periodic or not. Hope you understand what I am trying to conclude. Okay. Now, as we observed in time shifting, how your signal is being shifted. Now let's see in frequency shifting how the same signal will be shifted. So let me show you. When we are observing the frequency domain, let us talk about frequency shifting. Let us discuss about frequency shifting. Sir, in time shifting we saw what we saw. If I have a signal x of n, its correspondent shifting, its correspondent Fourier transform will be e power j omega. Yes, absolutely correct. If I am shifting this signal to plus or minus n naught, then we saw in time shifting its correspondent, what will happen, sir? E power plus or minus j times of n naught into omega. Correct, na, sir? Into x of e power j omega. This is the Fourier transform for shifting signal. But as we have been observed that this is for time domain. If this shifting occurred in frequency domain, then how should I write it, sir? So in frequency domain, people will be writing like this. X of, we will be keeping the shifting. See, everything we are writing in the power of e. So shifting also should be written like this. Omega will be shifted to an amount of omega naught. Either it should be negative shifting or positive shifting. If it is shifted there, then in correspondent, what will happen in time domain? That shifting will be represented in the power of e, undoubtedly, j times of omega naught into n. But what should I keep, sir? If it is minus here, I should keep plus here because frequency shifting will change the sign. These things we are observing from Fourier series, continuous time Fourier transformation. Now I am writing the same thing in discrete time Fourier transform also. So the conclusion is x of e power j times of omega minus omega naught, it can be written as e power j times of omega naught n into x of n. So what it is, suppose let us assume I am having x of e power j times of omega plus omega naught. Then how will you write? If it is omega plus omega naught, then here I can write it as, here I have plus, then definitely should be minus j times of omega will be replaced by omega naught into n, and of course here we will be writing it as x of n. Any doubt in this? Hope you understand what I am trying to conclude. Correct, no, sir? That's it. So this is how we are applying the frequency shifting property. It's very important, sir. You must remember what are the things that I am giving here. Next, let us enter into the another most important property, that is time scaling property. Before writing that formula, I would like to ask you, we have seen in continuous time Fourier transform, when I was discussing about in the last class, when I was discussing about continuous time Fourier transform, I wrote the formula like if I have a signal x of t, its correspondent Fourier transform can be written as x of j omega. Suppose if I have a signal x of t and it has been scaled by a factor of at, then how will you write down its correspondent continuous time Fourier transform? In frequency domain, it should be written as 1 upon mod a into x of, in bracket, this will become omega by a. Correct, no, sir? Sir, forget about j. I told j will be there. Sometimes people will be writing j, sometimes they will not write. You just focus on the property. This is correct or not? This is what I wrote when I was discussing about continuous time Fourier transform. Of course, the same property is true, valid here also. How it will be written? It will be lies in the power of e. That's it. And one more thing, what I would like to conclude now, sometimes people will be writing in discrete domain itself, instead of writing e power j omega, they will directly write x of j omega here itself. Don't get confused. Don't think that they did some changes. No. They either you can write it in this way or you can also write it in the other way. So don't be worried about it. Don't be think about it. Okay. So okay, chalo. Let's carry on. X of e power j omega can be written like this also. What we are discussing here? Time scaling property. If I have a signal x of n, sorry. If I have a signal x of n, its correspondent discrete time Fourier transform can be written as x of e power j times of omega. Absolutely correct. If it is scaled by a factor of a times of n, then what will happen, sir? In frequency domain also, you can observe its correspondent shifting property. How it will be reflecting here? So when we are observing the expansion or compression in the discrete domain, we have to understand one important thing. The another most important thing what I must observe here is when we are dividing or expanding this sequence in discrete domain, while compression, that is while compressing or expanding any signal, when the moment you are trying to compress or when the moment you are trying to expand the signal, what we have to keep in our mind is only integer values are allowed. Only integer values are allowed. So when the moment you are dividing the sequence, for an example, suppose initially in the frequency domain already the existing value is 2 radian per second. If I am dividing it by 3, is it valid frequency? Is it valid frequency if you are dividing by 2 by 3? No, this is not valid frequency. Though, so this frequency should be skipped. So while dividing it, you must be very careful that how to apply this scaling property when we are dividing this signal. Suppose if you are dividing 2 by 2, yeah, this is valid point. This will give you 1. Yeah, this is acceptable integer. Again, if you are dividing 3 by 2, no, you are getting 1.5, invalid. If you are dividing 4 by 2, yes, this point is valid point. So in these properties, you have to be very conscious when the moment you are applying the same property. You can write down in the same way as we are writing in continuous time domain. But what we have to do, when the moment we are dividing the frequency by the correspondent given constant, you will have to be very conscious that after dividing, whether we are getting proper integer or not. If you are not getting, skip that value. For the rest of things remain same. You can use the same property There will be no any changes in the property. Hope you understand. Next, let us discuss about time reversal. So the another most important property is time reversal property. So time reversal property means if I am having a signal x of n, its correspondent discrete time Fourier transform can be written as e power j times of omega. Then if I am flipping this signal, if I am reversing it by minus n, then what will be the correspondent Fourier transform? The Fourier transform, discrete time Fourier transform can be written as e power minus j times of omega. This is the time reversal property of the signal. Understand? So you must keep these things in your mind. So whenever we are applying time reversal, if there is any reversal in time domain, then in frequency domain also frequency will be reversed. Okay. Let's enter into the other most important property, that is differentiation property, but this will be applicable only in frequency domain. So differentiation property in frequency domain, directly you can write differentiation property in frequency domain, RF domain. When we are applying differentiation property in frequency domain, what will happen, sir? In frequency domain, you can differentiate a signal. In time domain, what will happen? So it is same. It is as usual. These things are same. We have already discussed. If I have a signal, if I have a signal x of n, its correspondent discrete time Fourier transform can be written as x of e power j times of omega. Yes. If we are differentiating this signal in the frequency domain, definitely you will be obtaining same formula, d into, that is j, operator j into x of e power j times of omega divided by d omega. That is the property. We can write down this clearly. Now the thing is, its correspondent value, how should I write it in time domain? There what you wrote in continuous time Fourier transformation, just recollect. T into x of t is what I wrote when we are differentiating the signal in the frequency domain. D times of x of j omega or omega divided by d omega. This is what I wrote there. Then we have also saw n time differentiation. In that case, it has been raised to the power of n. And here you can write d power n divided by d omega power n. Here what I kept, x of omega. If you are doing n time differentiation, then in time domain also I wrote multiple times t power n times of x of t is what you will obtain in the correspondent time domain. Same things are same, nothing will change here. You can write down it. Some properties will be same as it is. If I am doing it n times, then what will you say? If you are writing it in n times, if this differentiation has been written n times, then it can be written as j power n into d power n upon d omega whole power n into x of e power j times of omega. Omega we can write like this, or we can also write like this. What you'll be getting, sir? N power n. See, to avoid the confusion, I will keep something else. Wait. Keep m or p times differentiation like that. So n power p into x of n. That's it, sir. So this is differentiation. The next most important property is conjugate property. Conjugate property and conjugate property means if the signal is symmetric, then how should conjugate symmetric we have to write. I will say first of all, write down conjugate property. The next most important property is conjugate property. So if we are observing conjugate property, what can we say? Suppose let us assume I have a signal x of n. Its correspondent Fourier transform x of e power j times of omega. That's it. Now, if you are taking conjugate for this signal, it is given that in time domain that signal has been taken as conjugate. If you are taking conjugate for this signal, what will be the correspondent changes in the Fourier transform, sir? Same thing in continuous time domain also I wrote the same. Here also what you'll be getting, x conjugate of e power minus j times of omega is what you will be getting in frequency domain. It is given that x of n is a real signal. If it is given that the value of x of n is a real signal, listen. In time domain, if a signal is represented that x of n is a real signal, if it is mentioned that the x of n is a real signal, then how should you write? Then what will be the property in frequency domain correspondent? In frequency domain, what will be the correspondent conclusion is, if you are taking conjugate for a signal, then if the signal is the if the signal is the real signal, then the property can be written as x of e power j omega equal to x conjugate of e power minus j omega. There will be no changes. So what you can write is, if a signal is real signal, then you can write down that x of e power j times of omega will be equal to x of, after taking conjugate also what will be getting, since it is given that it is a real signal, then what is the point of changing the imaginary part? It will not be affected. So you will be getting the same answer. So x of j omega and x conjugate of e power minus j omega both will be remain same, sir. Next, the convolution property, both in time domain and the frequency domain, we will observe. If we are observing the convolution property of the signal, let us see. The other most important property is convolution property. If a signal involved in convolution in time domain, suppose for an example, let us assume I have a signal x1 of n. Its correspondent frequency, discrete time Fourier transform, can be written as x1 of e power j times of omega. Now let us assume I have one more signal x2 of n, and its correspondent Fourier transform can be written as x2 of e power j times of omega. Now suppose if these two signals are involved in convolution, x1 of n and x2 of n both has been involved in convolution, both are involved in convolution, then its correspondent frequency domain response. If two signals are in convolution in time domain, then in frequency domain you can directly multiply them. x1 of e power j times of omega dot x2 of e power j times of omega. Okay, this is what you'll be obtaining as the resultant answer. Fine, sir. This is convolution in time domain. Suppose if you are doing the same thing in frequency domain, it is same as it is we were discussed. We saw in continuous time Fourier transform. Now we can use the same formula. What we saw, there will be a factor has been introduced when we are doing the convolution in frequency domain. What is that? Your resultant frequency has been multiplied by 1 by 2 pi. Let's see. If I am doing convolution in frequency domain, convolution in frequency domain, let us discuss about convolution in frequency domain, convolution in frequency domain or F domain. You can directly say, or it is F domain. So how should I write down this? It means if two signals are involved in convolution directly in frequency domain, if it has been written like this, 1 by 2 pi in bracket x1 of e power j omega, it has been involved in convolution with the x2 of e power j times of omega. If it is involved in convolution, then in time domain they will be in multiplication. They will simply get multiplied. What you can say is x1 of n simply multiply with x2 of n. That's it, sir. That's it. But be conscious, sometimes what will happen is, as I told in continuous time Fourier transform also, if the factor 1 by 2 pi is missing during the convolution, then that will be included in the time domain. 2 pi times of, you will have to write x1 of n will get multiplied with the x2 of n. In frequency domain, you can write x1 of e power j omega simply involved in convolution with the x2 of e power j times of omega. That's it, sir. So this is how we are writing when two signals are involved in convolution, especially in frequency domain. Okay. So the next most important property, of course, questions are being repeatedly taken from the properties, especially for TRB like state government exams. What is that property? That is time differentiation. Differentiation in time domain. See the difference property. I will show you. Not differentiation, that is a difference. We are finding the difference between two signals. Same signal, but it has been shifted. I will tell you. Whenever they are asking you time difference, this is time difference property. What is this, sir? Yeah, it is the special version repeatedly asked in the examination. Whenever time difference will be given, no, nothing. You can directly take, for an example, I have a signal x of n. Its correspondent Fourier transform can be written as discrete time Fourier transform e power j times of omega. If I have a signal x of n minus n naught, then we know this can be written as e power minus j times of n will be replaced by n naught times of omega. You can write in this way, or n times of omega naught into x of e power j times of omega. Now first difference means this is first difference x of n, that is time difference. Whenever they are asking time difference, no, they will be doing time first difference. Actually, you can give the word clearly, time first difference equation. X of n minus x of first difference means n minus 1. X of n minus x minus 1. What can be the expected Fourier transform of this signal? Discrete time domain. Most important, repeatedly asked the question in the exam. Either they will find the first difference on the input side, or they will find the first difference on the output side. There are two things. I will show you. So for this, but that is general. X of n you can write, or y of n you can write. Either you can write x, or in place of x you can also write y, because first difference equation repeatedly asked for output also, y of n minus y of n minus 1. Sir, how should I write the transform for this? Very simple. For x of n, correspondent transform can be written as e power j omega. Yes. Then for minus x of n minus 1, it can be written as e power minus j times of 1 into omega. Sir, in place of n naught we have 1. That's it. In place of n naught we have 1 into x of e power j omega. Can I take x of e power j omega outside? Of course, x of e power j omega I can take it outside, sir. So inside the bracket you will have 1 minus e power minus j times of omega is what you will have here. That's it. So this is called first difference equation. Hope you understand, and you must keep it in your mind. Okay. I will tell you the another question that will be repeatedly asked. That is recently also in one test this question is asked. I will tell you. What they will do now. We know that if we have x of n, then its correspondent discrete Fourier transform is x of e power j omega. Okay, sir, this is fine. What they will do now, they will take x of n and they will generate a sequence from n equal to minus infinity to a particular point, p or k, something, whatever they will generate. Leave it as randomly some value they will generate. What can be the expected correspondent Fourier transform, sir? The most important thing. If you are putting into the formula, it will be correctly giving you the answer that it will become 1 upon 1 minus e power minus j omega into x of e power j omega. Sir, this is the answer, but I am saying this is the final answer. Suppose in the question, when you are solving in the exam, if the initial value also given, let us assume that initial condition x of 0 equal to something. If it is given like that, then you must consider, along with that, you must consider the initial value also. What is the initial value, sir? That is nothing. Pi into x of 0 summation, impulse train will be running here. So you will have to take randomly some value. Let me take q is running from minus infinity to plus infinity, and you will have a del of signal, and it will be, since we are shifting it, so this can be written as omega minus twice of pi times of p, as p is running from, sorry, p, not q. This will be q, 2 pi q. Now you can run. Sir, most of the time this will be vanished. They will not give this. You can make it as 0. X of 0 they will not give. Remember. If they will give, then you must remember pi into x of 0 summation q is running from minus infinity to plus infinity into del of omega minus 2 pi q. So you must remember, suppose if the initial value also be consider. Actually, there is a name for this property that is called a time accumulation. We are accumulating the data now from minus infinity to a particular point. So that's why it is called a time accumulation. Okay, just do remember this. What is the name of this property, sir? That is called time accumulation. Hope you will not forget. The another most important property. Next we are going to enter Parseval theorem. So next what we are going to discuss here is Parseval theorem. So let us discuss about Parseval theorem. Sir, we have been discussed about Parseval theorem. Let us discuss. See, continuous time Fourier series. What is that? When I was discussing about continuous time Fourier series, I wrote the formula for Parseval theorem. What I wrote? 1 by t integral of, we were running with the periodic signal in Fourier series. So 0 to t mod of x of t whole square into dt equal to summation n equal to minus infinity to plus infinity mod of cn whole square. This is what we saw. Now, when I was discussing about continuous time Fourier transform, I did the same, but what we saw, there is a difference. Here the formula will be minus infinity to plus infinity mod of x of t whole square into dt equal to 1 upon 2 pi. That will be a periodicity in frequency domain, and we will be running from, as usual, minus infinity to plus infinity mod of x of omega whole square into d omega. This is what we saw in frequency domain. Now, as we are entering into the discrete time Fourier transform, what will be the formula for Parseval theorem? So let me write down. So in Parseval theorem, we are in discrete domain, so I cannot use integration in time domain, but in frequency domain we can. I will tell you the another most important property is here summation n will be running from minus infinity to plus infinity. N will be running from minus infinity to plus infinity mod of xn, x of n whole square will be equal to, this is periodic signal. So here in the discrete domain you have periodicity 1 by 2 pi, and you will be suggested to go ahead from minus pi to plus pi, and in frequency domain x of e power j omega is what we are having. So e power j omega, x of e power j omega is what we are having whole square into d omega. That's it. So this is the Parseval theorem formula when we are doing the same thing in discrete time Fourier transform. Sir, this is very important. You can observe that even in the examination also, this question has been repeatedly asked. So it is very important to remember this. Don't forget. Hope you will not forget this. Okay, just to recollect multiple times again and again, revise it, register all the properties whatever that I am giving. As I told you, here my agenda is trying to complete the whole syllabus. Overall, doing this self preparation, you must know the complete syllabus. Without knowing the actual content what is required, you should not study randomly some books or study material. That may not be helpful for you. You should complete the whole syllabus. Then only you will be able to cover the total marks in the examination. Okay, that's it, sir. So we have completed the whole Fourier series and the Fourier transform. What is next? So in the next class, we are going to start Z transform. Then we will be touching sampling theorem. At last, we will discuss about basics of continuous time signal. That is basics of signals, every signals. I will cover all type, continuous and discrete. Signals under system. We will cover basics of system properties and signal property also. This is what we are going to do at last. One more thing, sir. Please visit our website. There you can find the test series for TRB. As I already told you, there are 230 tests has been uploaded. It has been covered all subject wise, chapter wise tests, which will be help you to complete the whole syllabus. I hope you all know the website name www.rkelectricalgrid.com. So just to try to write on the test. It will be helpful for you to get the grip with the subject. Fine, sir. This is all for this lecture. Rest of things we will see in the next class. Thank you all.